two quantities, the result thereof becomes a Boolean value, which is either going to be true or false. For example, if you say is 1 greater than, okay, we have is 5 greater than 3, yes, which is true. So true now becomes the Boolean value. So these are generated, we have that is to tell us that we can only produce the Boolean values when expressions such as this are carried out from comparisons or logical operations. Conditional execution. Python uses if, Elif, and what? Else statements to run blocks of code based on conditions. Example, we have this here. X has been declared as a variable and the value 10 has been assigned to it. Then we have this as a statement, a logical statement. If x is greater than what? 0, which in this case, this result is true because x, the value of x is 10, and that is greater than 0. So if x is greater than 0, print what? Positive. Elif, print x is equals to 0. This is the equality sign.
Yes.
You understand?
Yes.
To say that this quantity is equivalent to the other one. X on the left hand side is equal to, or the value of x is equal to 0, which is 0 is on the right hand side. So these two things are now equivalent. So this double equal sign is different from when you put a single equal sign. And if you put a single equal sign, that does not mean that is a comparison again. Okay? For comparison, you must put two equal. If it is single equal sign, what is it representing? Felicia. If it was single equal sign here, supposing we remove the other one, what is that representing? That equality sign there is representing what? Or the whole of that statement, x equals to 0. What does it represent? That represents assignment statement. You understand?
Yes.
That represents assignment. You have just assigned this value. Like what we have here, x equals to 10. This is not comparison. We're not comparing this from this one with this one, but we are simply assigning this value down. A memory in the a memory location known as x should hold this value 10. That is what it means. But when we now say x equal to 0, means we are now saying that the actual size of x is 0. The actual size of x is 0. We are comparing, okay, x equals to what? 0. Okay, so the next line on say print 0, s, print what? Negative. Okay, let's go over it again. From here you see the full column here indicates that your code, this is a block of code starting from here to this place. Let me take it to the next. Let me take it into this page so that you look at it very well. So this if statement starts there and ends here. If it were in any of these programming languages that uses as curly braces, we would have opened it here and closed it after this line. The indentation here, I told you that in Python you have to indent when you are referring to a block of code. I hope you know what I mean by a block of code. So you indent. The moment you remove the indent, by bringing this one to the same line with this if, it means that that if statement pauses there or it stops there. So Elif now introduces another line. That is to tell you in short for as if. You understand?
Yes.
Elif means as if. So in essence, we're saying that if x is greater than 0, you should print positive. Or if s is equals to 0, then you should print what? So this one also starts here and ends on this line. You should print 0. S, print negative. So there are three things here that are going to be checked. you are going to check whether x is equals to 0 or x is greater than 0 or x is equals to 0 or x is anything other than these two things. That means if x is what? Is less than. That is to tell you that if, apart from being greater than 0 and apart from being equals to 0, then the next thing is what? It should be less than 0. So if it is less than 0, then you have it as a negative number. And that is true because any number that is less than 0, any number that is less than 0 is a negative number. That is where you start having minus 1, minus 2, minus 3, minus 4, minus 5. You understand? Logical operators and or not. This we discussed already. And produces a true result if and only if when both are true. Then or produces a true result when one of them or when both of them are true. And then the only situation where it's going to produce a false result is when both of them are false. And in not, we know that not is an inverter. Only inverts the value of the original operand. Okay, bitwise operations. We have this. We have bitwise and bitwise or the bitwise XOR. This one, all those forms they are for bitwise operations. And we have examples here. I think this we'll look at this example one other time, isn't it? This is the actual value of 5 in bits. This is the actual value of 5 in bits. So the bitwise operations works with the bits, and the bits we have zeros and ones. That's the representation of bits. 0 represents 1, a false, while 1 represents a true. Okay, so this is the actual value of what? 5, and this one is the actual value of 3 in bits. So when we now print A and B, which is the bitwise AND, then it means you are going to have what? 1. You are going to have 1. Just add this. Sorry? What do you do? You pick this one and this. Check this one, this first row, second, third, and fourth rows. You get it, ba? So once you get 1 and 1 because of this AND, when you see one up and 1 down, you can have the 1. But when you see 0 up, 1 down, is 0. This one is also 0, and this one is also 0. So your bitwise AND is what? 1. The result will be 1. Almost the same thing as when you work with listing. Almost the same as when you evaluate your truth tables under logic. Is that clear? Okay, now let's move into the actual procedure on how to carry out this practical. First, we are going to open our Python environment and type this program. This is the program we have. We are going to type this program into that Python environment. Again, let me go to my VS Code. Okay, I have a document here already, but let me close it and come back so that let me come back. Prior to this, I have my folder on the desktop here, Python practice. So I open it with this. You simply click on File, go to Open Folder. You understand? Then locate the folder from the dialog box and pick the folder. Then click on Open. So that is why we have come to this place. So now there is no file in this. There is no file already created in this. So you can simply click on New File to create the file, or you can click here. While you tap here, click on this New File, and then it's going to create a file for you. But I prefer clicking this one, which now allows me to choose which file content I want to use. I want to use a Jupyter Notebook, so I'll choose this Jupyter Notebook and create my file so that I can run my course here straight away. Okay, now for me to be faster, I want to copy this code. What we have here is I'll copy them, then we'll look at how we can edit from there, copy it and come and paste. Alright, I paste it here. Already we have created a variable. We have two variables here, A and B, and their values have been assigned automatically. Sorry, they have been assigned already. We assigned the first with the value of 10 and the second with the value of 20. So here we have print A is greater than B. The whole of this is a string statement, so it's going to appear when you run this code. A is greater than B. Then we have A greater than B. A greater than B. This will produce the result should be what you obtain when you compare these two. Is A greater than B? Is A greater than B? No, so you should expect a false result after you print or when you run the code. A is equals to 10. The second one says print A is equals to 10 and B is what? Equals to what? 20. This is also a comparison. Look at it here. A is equals to 10 and B equals to 20. This one is true. This from here to here is what? True, isn't it? Because actually A is 10, isn't it? The value of A is what? 10. And the second one, the value is also 20. And it means that both this expression is a combination of this expression and this one. It means that this is true and this is also true. Then look at the operator in between. That's a logical operator, comparing the two of them. Comparing this operator, which is also a comparison, and this other operator this side. I mean, this expression this side, which is also a comparison. So since this one is true and this one is also true, it's going to produce a true result. You understand? Then we come to this one, which is not A greater than B. It's going to evaluate A is greater than B first, then it's going to negate the value, the result after everything. So that's why we have not A is greater than B. A is greater than B will be what? A is greater than B will be false. So you should expect that this line of code is going to print what? It's going to print what? True result. You get it? You try to compile your code by your head, by knowing what you are doing first before you run it or you write it. You understand? That is the advantage of programming with high-level languages. You know what you are doing, exactly what you are doing. You know it.
But this down one is false. This down one, the last one is false.
The last one is false. How is it false?
Because they say not A is less than not A is less than B. A is less than true.
You will first of all evaluate this. No?
And then A is less than B. But they say not. That means you say that A is greater than B. But it's not there. There's a conditional statement there that is talking about not.
Not A
less than B.
less than B.
While the variable shows that A is less than B.
Okay. So you are insinuating that when you run this, it should be a false result.
Yeah.
Okay. Okay, because logical not comes first.
Yes.
Okay. You may be making sense. Logical not is evaluated before one. Wait. I don't think that should be the result. Let me see first. I hope you have tried it yourself and it works very well. Good. So I'm moving to wait. Okay, that's 3.2. Number 2. Write a conditional program that checks if a number is positive, negative, or what? 0. So we have this one here. Num is equals to int input. So this is going to get a value from the user.
Yes.
And this
Value will be in.
this value is typecasted.
Yes.
Do you know what typecasting is?
Yes. Means that you must insert an integer value.
No, typecasting is a process of converting your value from one data type to another. So I think it was in this class I told you that what you use input statement, what you enter on the keyboard from the input statement is a string, is of type string. So you cannot carry out any other operation other than string operations with it. So unless you convert it to integers or any of the data types before. So this is the way we convert it to integers. You first of all write int, then open the bracket. Inside the bracket you now put this function. Input, then enter this. So whatever the user will enter now will be converted to what? Integer, to be seen as an integer value, and it will be assigned to this variable num. So if num is 0, print positive. Elif num is equals to what? 0. Print 0. Else it should be what? Negative. Just what we experienced, we saw there already. So we're going to write this now. So we start by writing num equals to int. I hope you are following what is happening. Int, then inside the bracket we have input, then we open another bracket and write enter. We are now using our IDLE, so this is how we are going to do it. Enter a number, enter a number, and this is going to be a message that is going to be prompted for the user to enter any value. Enter a number. Yes, it's there. It's closed there. Have you not seen it? And close the bracket. All the brackets that you open, make sure you close them. So let's press enter. This one will now require us to run it after we finish writing because it requires the user's input. So we're going to type everything. If num is greater than 0, right? Make sure you write 0. 0 is different from letter O. Do you know that? Okay. You see that this one is indenting by itself. I hope you follow what is going on there.
So this one must I indent it?
Yes, if you don't indent, it's not going to run. That's the requirement. So we're going to print in bracket and a quote positive. Positive. Let me add positive numbers. This is a positive integer. You can change it to suit whatever you want there. After all, this one is going to be printed. It's going to be shown on the screen. It's positive. Then here we want to come out of this. So you must remove the indent now by pressing the backspace on your keyboard. You should follow what I'm doing here, please. Bemshima, sit down and pay attention to what is happening. Then we type Elif. No. Is equals to 0.
2 equals to what?
Num is equals to 0. Full column is there. That shows that you have started a block of code from there. Anywhere you see full column in your program, or anywhere you are writing full column, means you have started a block of code. Print. You can put it inside a bracket. You can just say the number entered. You can simply say the number entered is a 0. Is a 0. Put it this way. It's a 0. And close it. Okay. S. Still remove the indent by pressing the backspace and then it removes. Then you write S. Full column again.
Yes.
It's going to indent by itself. Then you are going to print. Print.
Negative.
The number entered is negative. Okay, the number is a negative 1. Negative 1.
It's negative.
Yeah. Okay, I think that's the last line. We are trying to see, in this, we're going to see how the condition statements work. I think let's save this file. Save as. Save as. Let me choose the, okay. Let me save it using my file, Python practice. Now I save it. Condition dot py. Okay, let me remove this. Okay, condition one dot py. Condition one dot py. Save it. Okay, saved now. So we will run it from the IDLE, Integrated Development and Learning Environment. Click on this one, run modify. Okay, it has started working. Enter a number. What number do we enter now? Number 8. Press enter on the keyboard. Positive number. So the number is a positive 1. Because it is what? Which of the code segment works here? Here is it. This one. Positive numbers. If number is greater than 0, it should be positive. It should print is positive. And so it's greater than 0. Let's run it again and try with a different number. Okay, let's enter -2. Okay, the number is -1 because it made a comparison here, and this is false. It's only the one that will be true that will be executed, because if num is greater than 0 and -2 is not the same as this. Then here number is equals to 0. No, it's not equal to 0. Then as if the number is what? Negative. It's a -1. That's what print. So let's, for the last time, run test for 0. Let's test it for 0 number. Let's test it for 0 number. The number entered is a 0. That's what I put here. The number entered is 0. So with that, we are able to explore all the conditions available. We are able to explore all the conditions available for positive, negative, and negative numbers. So you can see that if you have more than 2 options, supposing we have only 2 options, we would have said, okay, it should give us either this one, S, this one. So there shouldn't be any need for Elif. Are you getting me? So the Elif, typically we use it when you have more than 2 options available. When you have more than 2 options available, then you can make use of Elif. But if there are only, what if it is only one option? If you have only one option, there is no need for Elif, there is no need for S, you only have if. And that only executes when the condition turns to be true. Yeah. So that is that for that one. Let's move on down. Let's see if we can be able to do more. Number 3, experiment. We're now going to work with Bitwise. And this has been given here. X is equal to what? 6. And Y is equal to 3. These are their bit equivalents. You understand? Now, I don't know whether I told you that if you want to write this, if you want to use comments in your program, what do you use? Use hash symbol. So the hash symbol is used to tell us the actual interpretation of these values. Yeah. So you may choose not to use them, or you can choose to use them. So let me just type this program. X is equals to Y. Sorry, X is equals to what? 6. Y is equals to what? 3. Python programming is very friendly, very, very easy to do, to work with, because you see that you don't even need to terminate your statement. You don't need to specify that this statement terminates here, and then you continue to write. The next page now, say the next codes now, they write print. We're going to print we want to test for what? We are going to test for what? What are we testing for here? Bitwise and.
That is,
You understand?
give letters. That
Or you can just put it bitwise and here. Bitwise and. Bitwise and. Or you can even customize it. You can even say bitwise 6 and, or you just say bitwise x and what 3 sorry x and y. Let's just say bitwise 6 and
so this one is it common?
bitwise 6 and what and 3. Is that okay? This is what this one in quotes is going to be displayed. You know that it's not going to be the compiler will not work on this one. It's going to be displayed. It's only going to be displayed like that. So semicolon, sorry, comma. Then we now command the compiler to evaluate x and y, x and y, x and what, y. So this is the only section that the compiler is going to work on. This x and y is going to execute it. But for this portion here, it's going to display it just as it is, as a string. Is that clear? So let's move down and still write. Print. We want to test print. We want to test that bitwise or print bitwise. Sorry, bitwise 6 or what 3. Then you write x or y. Is that so? Okay, sorry. Okay. That is a symbol. That is a symbol that we have to use.
Look like I, right?
Can we be able to get this symbol on this keyboard? No? That symbol. If you cannot get this symbol, then you need to go to your text editor and then insert a symbol. Let me see where I can insert. Okay, I have it here, so let me just copy it from here. Let me just copy that symbol and then put it here. Okay. Alright. Then I'm also going to test for exclusive or. Bitwise exclusive or. Just print. Exclusive or. Exclusive or. Let me just put it that way. We no longer use 3, 6 and 3. Exclusive or. Now we write x exponentiation what y. That's a symbol we use for that. Then we are going to print what? Test for what? Not. Bitwise not. Bitwise not. We test for x, right? Not x. Not x, sorry. Not x. Remember, it's going to deal with the bits, the numerical machine, which will have 0, 1, 0, 1 there. So that's what it's going to. It's going to negate all the, you know, it's going to negate all the bits values. Not the symbol is what? Okay, we have a symbol here. That symbol is not. That's not the symbol. So the symbol is found here on my keyboard. Is it this one? No. Shift this one. Alright, that's the symbol. X. Okay, go to the next line. Print what? X shifted left by 2. Print x shifted left by 2. Do you want us to run away from here? Python is not easy. I see that Python is not easy. It's just proving to us that Python is not an easy thing. Okay, shifted by 2. Where? Okay. A comma there. Then we write x double less than 2. Okay. Yes? Who is that? Benshima, leave that place. Benshima, I don't like that. Benshima. X. Sorry. X shifted right by 2, but okay, by 1. By 1. Shifted right by 1. Okay. Then we have x double greater than 1. Okay, so let's save this work. Let's save it as bitwise. Bitwise dot py. Let's save it. Now we can run this file. Click here to run. Okay. Now, unless you convert this to a bit, that you see the work. Unless you convert this to bits. 6 and 3. Let's work on this one. 6 and 3. If it is 6 and 3, we have let's go to the raw file. We have 6 and 3. What's the result? This one and this is 0. This one and this one is 1. This one and this one is 0. So if you have 0, 1, 0, what is the value in bits? Convert it to binary. Is that not 2? That is 2. So that's the reason why we have the result here. The result here as, sorry, where's this one? The result is 2 here. Then for this one, 6 or 3, you have 7. 6 or 3 is 7. So when you go there and convert this, here you have 1, 1, 1. Is that not so? Is that not so? So for 1, 1, 1, let me just put it here. The first one is 1. The first one is what? 1. While the second one is 2, is a 2. And then the other one is what? A 4. So if you add this 4 plus 2 plus 1, what do you get?
7.
You get 7. So that is why it is 7. I don't know whether you get what I'm saying here. I don't have a mark. I should have demonstrated it on the board. But that is it, because it's in binary. If you like, convert binary to, convert 7 into binary, and then you see the result. It's going to reflect what we have here. So that is how it's going to be for all of them. And if you convert all of them, you see, you can appreciate better what is going on there. Having done that, we have come to the end of the practical 3.1. The rest is, the rest of it is this activity. Student activity has to take place here. You are going to do this. Task 1, fill in the blanks with the correct Boolean values. Print 4 is less than 7. You should print the answer there. Print 5 is equals to 10. Put there. And this one, put the result there. Task 2 requires that you write a program that accepts a student's score and prints pass if the score is 50 and above, and then fail if the score is below 50. You understand? You can make use of this codes here. You can collect the input, turn it to what? Integer, and then make use of it. And we have more than 2 options, I think so. Do we have more than two options, or you have only two options? So if the value is greater than this, so you are going to use if and else only. If and else only to do that. So then there's space for you to write the program. Are you there? Then task 3, try the following and record the output. A equals to 12, B equals to 5, print A and B. This is bitwise. Where you see a single this. That is for bitwise. Now, if you want to use logical AND, this is double of this. You understand? This ampersand, right? This ampersand, you put it double. So if you put it double there, it means logical AND. So that is A and B, and then you write the correct answer. It should be a true or a false. But for bitwise, you know what it means. Convert it to bit. Is that clear? And the best way you do it, just go and use your IDLE and write the code. You get the result and then put the output here. So the output we take on this line, the two outputs are going to be on this line. This one is logic or, sorry, bitwise or. You understand? So I do that. Then the last part of it is this short answer review. What a Boolean value is, sorry, in Python. What are Boolean values in Python? Write the syntax of this Elif, sorry, if-else statement. Then what does the bitwise not operator do? You just write the answers there. So you'll be evaluated based on this. Okay. So that's all you need to do. When the practical manual comes, you work on it and give us what we want.